How's it going, everyone? Welcome. Today we're going to talk about now this component integration or this component testing, which is part of a series, or in this case, the course of enterprise UI development. This is now a model from this course where the idea is to now understand what are the things that we need to first know as a way to make a maintainable code, all right, that we have the ability to add or change or migrate or do a refactor without the fear of breaking something, and understand also how we're going to lay out the foundation, the infrastructure, the basic installation needed to make that happen, especially for big corporations or for large code bases with a wide range of contributors in large teams. So because of that, all right, I don't want to describe what we went over through all of this. This is something that is for another video. So far we have looked at this three particularly sections as a way to first understand what maintainability is, what are the components of a well-architectured UI that you need is the testing system, the build systems, as well as your static analysis. And then on top of that, you're going to have some process that allows you to now check some of these common things that happen when it comes to maintain your code. So for example, code review or code review or a blueprint designs. And then on top of that, what are the patterns that arise, especially as we need to actually create our user interface in a maintainable way, which is, hey, right now at the current state of the web, we use now things like an state management. Why is that? Because now we're putting all of this heavy lifting to the client side by now letting the browsers running the vast majority of all of this interactivity and this kind of operation, because now end device has much more power, and as the year combines, now it has a lot of memory as well as computational power. So there has been this trend in web development to move on from the traditional way of serving content from a server to a now, depend on the use case, single page application. So for example, back office is one good example of this single page applications. However, when you need that application need to be ranked for any of these search engines, okay, when SEO is something important, well, you might want to actually have this server-side rendering, right? And how now they come out with some sort of this rendering mechanism, such as single page or server-side rendering or incremental while revalidate, and all of these different strategies for this, most of the time, big companies to actually try to depend on the use case, which most of the time is, if you want to make your app be indexed, so SEO is important for you, so you go with a particular rendering mechanism. If that doesn't important to you, let's say you want to build a back office or a game application, all right, this is another approach. But again, I will argue that this is something like introduce a lot of complexity. In my case, unnecessary complexity. But again, this is just my opinion. At the end of the day, most of those applications is just we are using React and Redux and Angular and Vue, but it's just to handle now companies that have to deal with massive amount of data and interactions, right? And most of the time, the company that you're going to work with, at least if this is a startup, they're not going to need to handle all of these edge cases, right? But it is important to know that they exist for a reason, okay? In the case of Vue, in the case of React, is to solve the Facebook problems, and in the case of Angular, is to solve now these big companies and also any large code bases. And also in the case of Vue is to solve now some of these most common problems that we find in frameworks like React and Angular, right? And to actually close the gap by providing a rendering, a reactive compiler optimized rendering systems. Again, back here to what we care. This introduction is about this, and then we look now at the several topics that we're going to discuss here, which is one of them is this testing environment, okay, which is a spectrum that you can apply to, all right. So testing environments, followed by so you have unit testing, which is testing, which is a spectrum. Where you have now on one side of the spectrum the unit testing, and if you move on to the other edge, you have the E2E integration testing, and in the middle you have now this integration and components testing, which is something that we're going to talk about in this video. So after we know what unit testing is all about, which is, hey, is this function do what it's supposed to do? Great, good. In the intrinsic or some of the process of how you're going to write your tests, especially if you follow the TDD, which is not only so not only take a problematic things, write a test, write a failing test and an implementation to make it happen, but also, have the ability to refactor those tests and refactor your code. So again, here we look at how can we use a specific tool, which is part of the thing that now is on demand. So for example, like Vite, and how now Vite is something that is, I will say that this is now the spiritual successor of Webpack. Where back in the old days we didn't have anything like models, so we have now this model bundler as a way to now is using HTTP1. We're gonna send all of this data, HTML, CSS, and JavaScript per request in a compressed way. But now it has become an anti-pattern, right? With the use of HTTP2, which now allows us to multiplex it. It shrinks the headers, or it compresses the header. It allows multiplexing, which means is that in one request we can now send streams of data, all right, with an HTTP streams of that, and also this thing called server send event. This is now a technology that servers that use HTTP2 now can have access that facilitate is establish a persistent connection with the server, so you don't have to actually manage that for you, which is a great thing. And also is now this communication from server to client, right? So instead of client to server, we now can have is this communication, which is something that we can use in your chat applications, rather than implementing this duplex communication or this two-way data binding, which is now come from HTTP1. Again, in any case, the thing here that this unit testing is all about that. It's just a way to make these things work as expected. We're using now is Vite as a successor of the Webpack, because now Vite is much more EXIFS compatible. So now we can work with models. So we can now have in JavaScript have models, which is a great thing. Back in the old days, we have something called like immediately invoke function expression, which is just creating a closure and then you call that. Again, now we can use ESM, okay? So Vite is actually now allows not only to spin up a dev server, but also to close the gap between the testing environment. So the tools that we need to actually develop our applications and test our environment and test those. So this V-test particularly, now we can use is, for example, Jest, which is the way of how now you write your test, the way to actually make that everything works as expected. Unit test, component test as well, an integration test, which is a great thing. This tool is now written in Go, unlike Webpack, which was written in JavaScript. So it means that now HTML and builds are much more are faster than ever. How many times is fast? You can take a look at the website that is 10 times much faster than there is also a ESBuild, for example here. To transform or to build. No, but I wanna exactly it's this one. It's actually is taking too much time. It's 10 to 100 times faster than other JavaScript model bundler solutions, right? Which is a great thing. And also thanks to everyone who put an effort to this, because again, it's something that is not that easy to do. So shout out to all of you that actually made this possible. So it is written in, it used ESBuild, which is now is written in Go. So anytime you actually now spin out the Vite and or V-test, you actually now is running is this Go instance. To bundle is the application. Let me actually ask ChatGPT or in this case Perplexity if this is true, right? Let me talk about Claude and say, anytime we spin up a dev server or a test environment with V-test with Vite, it is safe to assume that behind the scenes we are running a Go program. It is not accurate to say that a Go program is running behind the scenes. Instead, Vite primarily operates within the JavaScript ecosystem, leveraging the Node.js runtimes. That is okay. In summary, while Vite provides robust tooling for modern web development can simultaneously various environments, it does so through Node.js rather than Go. Therefore, any assumption about running a Go program when starting a Vite dev or test environment is incorrect. Okay. Okay. So at the end of the day, is running it. Okay. At the end of the day, is running a Node.js instance. Okay. No, Vite is built on JavaScript, Node.js, not Go. It uses ESBuild, which is written in Go, as a dependency for certain operations like transpilation, but the dev server itself is an okay. So for searching operations, now Go is written. So it is safe to assume that anytime we build or transpile our code using Vite, it is running a Go program behind the scenes. Not entirely. Vite use ESBuild written in Go for JavaScript, TypeScript, transpilation and bundling during development. But other build operations like CSS processing, okay. Okay, but other operations, but other build operations like CSS processing, asset handling, HTML use JavaScript-based tool. The Go part ESBuild handle just the GS and TS transformation piece. Okay. So it is safe to assume that the transpilation phase in development when using Vite behind the scenes it use the Node.js binding to call a program written in Go. Yes, that's correct. Holy fuck. My God. That's a lot of nuances. Yeah. So it is safe to assume that the transpilation phase in development, when using Vite, behind the scenes, it used Node.js binding to call a program written in Go. Holy so this of course speed up the HTML. This of course speed up the HTML. Yeah, this of course speed up the HTML. The HTML. Okay. But not the build process, since it used Node.js libraries to do so. Right? Oh my God. Actually, that's not quite right. Vite used ESBuild, the Go program, for both development and production build when handling JavaScript TypeScript. The key difference is that in development it only transpiles without bundling, while in production it does full bundling. The speed benefits from ESBuild apply to both scenarios. Okay, because it is doing for the development and production here, but for transpiling. Okay, so it transpiled JavaScript and TypeScript files. Okay, it transpiled JavaScript and TypeScript files in development as well as production, and nothing more for now, right? Not quite. ESBuild, the Go program in Vite, also handles CSS processing and JSON import, both in development and production, but its primary role is indeed the STX transpilation and bundling. Okay, it also handles CSS processing and JSON import. This is something important to actually just recap. And thanks, according to Claude, is this one, right? And according to Claude. So now things are starting to make a lot of sense, especially when we're using now is this Vite, which is what it does is to speed up a Node.js server that behind the scenes is communicating the node binding. And let's go to take a look now at the Node.js architecture. It's important to do this quick recap here, right? Oh my God. For real? Jesus. What if I want to take a look from the, not from Turing? Come on, man. Oh, okay. But this is the event loop. I'm more interested is on the node architecture, not the event loop. You know what I mean? How to install the different JavaScript engines, the compilation phase, an introduction to the npm package manager, ECMAScript, EXIS, and beyond. WebAssembly, security profiling, Node.js application TypeScript, asynchronous work, manipulating files, command lines model. Is this for really? You're not going to show that? Wow, branding, Node.js, interesting. Oh my god. Yeah, but the question here is that, wow, what is the architecture? Provide me an architecture link from the Node.js website. But this is the about page. Yeah, but this is the about page. Oh my god. Oh my god. Oh, for real? Additional research? So is really? Wow. I cannot believe it. Wow. That's highly counterintuitive. Oh my god. Oh. And there is no diagram. There's no. Please provide me a diagram of an architecture link. Wow. But it's from Scalar. Yeah, it's like but damn son. Wow. I'm quite amazed. I am quite amazed that it doesn't support. Okay. Oh, this is the architecture. Our environment API. Closing the gap between build and dev. Exactly. Browser environment, Node.js Volo, Vitesse.js in a worker threads and a worker environment. Okay, but again, this is the environment. Formalizing environments and closing the gap between build and dev. All right, here we go, bro. Again, that's quite interesting that they don't even show about this architecture, this operation here, right? That is quite interesting here. That is very, very interesting here. That is very, very, very interesting thing here. Yeah, absolutely. You know, absolutely. And they don't show is a visualization. That's quite interesting. That's quite interesting. That's quite interesting. That's very, very interesting here. Oh my god, it's like, all right, Jesus. Anyway, So am I not looking? So Node.js architecture. Perhaps I'm not looking right now. I'm not looking right. So diagram. But this is from Medium. It doesn't. Node.js doesn't actually show that. Okay. Node.js architecture single thread event loop. Exactly, but this is a web server. But this is the diagram. I mean, this is a Node.js server. Internal thread pool. Okay. Um. Okay. That's interesting. This some sort of black box that is here, which is interesting because Node.js they don't show that. Node.js per se doesn't show you that. Okay. Node.js doesn't show you that. Okay. Quite interesting. Not that interesting, by the way. So, anyway, well, it's like, it's like, So it's like, Diagram Node.js book. Okay. So Mario is currently the CTO of the H4 technology, where he creates software for emergency management. In the past, Mario has worked at IBM as a team lead and also founded a couple of software companies. And Luciano is a senior architect at 4Theorem, where he is helping companies to get the best out of the cloud and AWS. He's a speaker, and in the last few years, he has delivered more than 130 talks in conferences and meetups around the world. This is quite interesting. Boy Kill edition. Exactly. This is the way how now is explaining to that. That's very very interesting. Very 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 interesting, man. Okay. Hmm. That's quite interesting. Hmm. Uh, but again, well, okay. Again, I don't want, I don't want to get deep into the weeds for this. I just wanted to mention that anytime you are now running is the transpilation phase in development and production, as well as the CSS. No, okay, I lost it. As well as the CSS, as well as the CSS. Okay, we're experiencing a high demand. Consist response will help you chat more with Claude. As well as some CSS processing and JSON imports. But it's very specific things that now is handled. So by the time now this Node.js instance, which is the Vite server, it now needs, and here's the interesting part here, it needs to transpile from TypeScript to JavaScript, whether it's on development or on production. You're gonna use now ESBuild for that. This model bundler reading in Go. How it's gonna do that? By actually is through communicating through the Node.js binding that will call that file. So it is safe to assume that any time during development, okay, so anytime during development and production, when we need to transpile TypeScript to JavaScript, process CSS and import JSON, we are using a Go program. Exactly, we are using a Go program through the Node.js bindings, calling that program. Yeah, that's exactly right. And this is something important to understand the subtle difference with Vite, right? So anytime during development and production when we need to transpile TypeScript to JavaScript, process CSS, and import JSON, we're using a Go program, ESBuild, through the Node.js binding, calling that program. Holy fuck, man. When in development and production, it uses ESBuild, which is a Go program, accessed through Node.js. That's something interesting. Okay, why I make this thing here, especially with the Vite, right? Setting up Vite test. Okay, important note. So important note. Vite is a model, is a bundler. You can say this. let me actually say, is this actually true? So Vite is a model bundler, a dev server. So what is Vite, bro? The build tool for the web. Okay, the build tool for the web. Exactly. Okay, the build tool for the web. So Vite is a build tool for the web. Can you describe quickly the things that it involves? Exactly, all of the things, right? Dev server, so hot mode reload, fast startup using native ESM, build process, code transpilation, bundling for productions, and asset handling, plugin system for extensibility. I think you retry. On a single source, exactly, and should carefully scrutinize a high-stake advice with CLA. Exactly. So development server, build process, framework support, optimizations, and plugin systems, right? Is the build tool for the web. So it's a development system, something that we can assume, okay? It only transpile code as requests on demand. You got a developer server, you got a build process for actually generating all of for the transpilations, for the CSS transformations, whether it's CSS pre-processing transformations, asset management, code splitting, and production bundle, framework support, optimizations, and plugin system. But there is something also that is missing here, which is yeah, there's something missing here, which is testing environment. Well, that's what we have now, Vitess. Okay, that's what we have now, Vitess. But Vitess is an environment, right? It's a server that is running. It's a server for your. It's a exactly. It's a server for. It's a server running your tests. Okay. So again, the idea of this is to understand that so Vite is a build tool for the web. Okay. That is doing a lot of things, bro. For the web, that involve exactly that involve is development server. It's a development. It's that involve development, production, bundling. Because at the end of the day, is that is build process. So build process, as well as framework support, optimizations. Okay, so optimizations and plugin system and plugin system and plugin system, right? And plugin system. Why am I actually make this quick recap of Vite, right? So Vitess is a Node.js environment for your tests, right? That's what we're using is this. So Vite is Vitess is a Node.js process for running your tests. Exactly. So it leverages ESBuild, the Go program, for code transpilation during text execution. Okay. In which other area ESBuild is used in Vitess? Code transpilation, transform test files, bundle dependency needed for tests in handling TypeScript and JavaScript GSS transformations. The main testing logic and test running itself remain Node.js based, but it's like that. So Vitess is now a Node.js environment that, for your tests. And this is something important because as we move on to the other things, we're not going to dive deep into that. Just to briefly describe the unit testing, remember that the end of today's video is just to jump straight forward to what component testing are, and just describe briefly each one of those topics previously, right? So this is how we look at how can we do our unit testings and how is using Jest behind the scenes, and how now Jest is this language that allows us to write our tests for our functions. You can also use that for your integration testing and component testing, which is something that we're going to do here. And also when it comes to actually write your unit testing or your tests, well, follow a particular pattern or discipline, which is define your tests or define the setup of your tests, followed by the testing logic and your assertion. Okay, so make everything here at a glance. Don't actually use a model for other things. No. Put everything here in a glance, because especially we don't want to actually dedicate too much time to write our tests, right? That actually makes a lot of sense. That makes a lot of sense. A lot of sense. A lot of sense. And once we look at how can we now deal with this synchronous testing and the asynchronous testing and some of the techniques to handle that, then, well, anytime we want to integrate some code, we would like to now run this particular test and build process, so we can make sure that we don't break the entire application. Again, part of the confidence of having a maintainable code base for companies. So this CI/CD process, again, I'm not going to dive deep too much into this. It's just a way of how you can do all of these code integrations. Most of the time we use this particular tool called GitHub that allows us to actually define is a workflow to run based on a particular events, specifically in your GitHub repo, in your repository. So it can be as one of these event listed that they have, or a schedule that you, some cron jobs or a scheduled job that you want to run at some point in the future, or right now, or periodically. And anytime you want to actually send an HTTP post to a REST, to an API, right? As a way to trigger is a particular workflow. Now, some of the most common use case of GitHub Actions is, for example, well, when you want to build and test, when you want to run the build and test on PR, or when you want to now bump up the npm version of your open source to npm, so you can publish that. Anytime you want to make a new release you wanna put a tag on that, or when any issue, or when someone make an issue, create now a label about that particular issue, right? So you can quickly identify what is the main cause, and how we look at the anatomy of the workflow, which is made of the events and the jobs that can run in parallel. These jobs is a series of steps that runs or that are executed in a runner. So the steps are bash scripts or actions. This is now a custom GitHub actions for complex, repeated, tedious tasks. So, for example, like setting up a build tool, setting up a tool change in your build environment. Set up a tool chain for your build environment, or when you want to communicate with third-party services, set up an authentication for third party, or you want is to now catch dependencies as a way to speed up is the execution of your tests or your build process. Also, anytime you want to pull a repo, all right, to this runner, to this virtual machines that is provided you by GitHub, where you have now is whether it's OS, whether it is Windows, Mac, or Linux, and also you can now run your tests in each one of those environments, right? You have, this is known as the matrix. Again, this is getting into the weeds. The whole point of this is to understand now that GitHub Actions is this part of the CI/CD process when it comes to integrate code with a wide range of contributors, okay? And there is a particular workflow or a file we defined to actually is, most of the time, run our test and unbuild process on NDP era, okay? So this is the most common use case. Then you're gonna find out all of those that are more relevant. And then now, as a way to speed up that process, all right, to check that to make your test and build process quickly, to make your build and your test process run quickly, we look at something known as catching, and how you can now protect your branch. And this is when we get into the weeds with security and compliance. Again, I'm gonna make it very short because this is part of the way of how now companies are securing their assets by following this particularly SASE model. This architectural way of how you can combine is the network connectivity with network security, and they have now several principles that you follow when it comes to build this, because companies they don't want a layer around those applications. They want now security was built in their applications. So that's why you have now this SASE, Secure Access Service Edge, okay? And some of the principles that it follow. Zero trust policy, that inside of this zero trust policy is, hey, instead of actually is assume that the risk can only happen outside, let's also assume that it can happen inside, right? Unlike some traditional models like the castle and moat, that's how things were doing back in the old days, that somehow is going to protect ourselves from access, and that has been like a losing strategy. And now you have more different approach in terms of security, like encryption, okay? So this is one of the principles of this SASE, despite it is a spicy name. So SASE, and also You have no zero trust policy, which is one of these principles that we have. As well as this zero trust policy actually has several principles you must follow. For example, is continuous monitoring and verifications, device monitoring, principle of least privilege, and also you say, hey, let's go to now is segmentate the network, micro segmentations, that when an attacker get in, it can avoid this lateral movement. So it is for them very hard to move across different network resources or business network resources. And we want to also implement is the multi-factor authentication anytime he wants to actually is trying to access to one of these services. It's a very interesting approach. Then also you have in the SASE, we took the principle we mentioned, or the principle that I mentioned was the yes the how do you call it? How do you put it? Yeah, do you have SASE in all of these principles? Zero trust, zero trust network, zero trust network security, the secure web gateway, where here you say, hey, now it is. Again, this is just summarizing some of the principles. It's like, let me now check the package that are passing through this, right? I'm gonna decrypt, check, analyze, and decrypt. I'm gonna decrypt, analyze, check, and if everything went well, all right, encrypt that again, send over. We also have another principle, which is the CASB, a very interesting thing. The cloud access secure broker, which is a set of solutions. You can pretty much think of like a security, a physical security firm, where they provide you now several services. So food patrol, surveillance, verifications, and that kind of thing, right? So here is actually now providing you is this set of services that they must follow is this set of principle, which is data protection, compliance, surveillance, and integrity. If I recall that right, and integrity and now that we are looking here, yeah, let me do this CASB, right? According to all of this is according to Cloudflare, right? And threat protection. Okay, so compliance, data security, visibility, and threat protection. This is the 4 pillar that CASB security, which is now defined by Gartner, this influential industry analyst firm. Okay, good. Awesome. So now going back here to, this is just to describe is this particularly security model that company are using that, and the other is the compliance. So what are the several compliance that most companies need to follow? Whether it's ISO 9001 for quality management services, ISO 4001 for environment management service, ISO IC 27001 for information security management system. All of these are just requirements made by the ISO, the International Standard Organization. You also have now the data protection, the payment card industry data security service, as well as HIPAA, and the Fed risk. I think it is. This is a way to manage is the risk of how of this company are assuming. Another important is SOC. SOC is another one, which is now the TLDR of this is to guarantee if the applications or the software that you're building actually is in the best interest. So hey, can we trust in this application that it do what it's supposed to do? Well, I won't say anything. And this is something that is conducted by the American Institute for Certified Public Accountant, I uh, AI AICPA. Uh, so now we finally reached to what we care about here with this components testing. After an almost an hour talking about this, it's because it's all of the things is important to having organized in your mind, having a structure here so you can quickly access to them. Give me a second here. All right. Uh, so enough of me talking. Enough of me talking. So component testing. At once, my friend. At once. At once. So component testing. Here we go. All right. Okay.
Let's talk a little bit about component testing. So component testing is that kind of next level up from the hierarchy from unit testing.
Building a CI pipeline with GitHub Actions. Oh, so he organized. Okay, that's interesting. Enterprise user interface development. That's quite interesting. That's quite interesting. Very, very interesting. Executive director. Oh, that doesn't exist. That's interesting. Mm-hmm. Ruby Elixir and Jasper Engineer. Interesting. Because Ruby on Rails is something that was in demand back then. That's what happened.
Right, unit testing super easy. Call function. Did you get what you expected to get? That works. And component testing is like the next phase up from there, which is run code. But like for code that you can't just call as a function, right? Code that has one very specific side effect, right? Technically, I guess, React functions, React components are these days functions, and I'm sure you could call them. But like good luck testing like on click handler. You know what I mean? Right, for those kind of more important pieces. Like, could you unit test a React component? Yes. Could you unit test a React component? Yes. Should you? Probably not. Somebody's gonna have like I have an important use case, and yes, then do it. But for the most part, like we're trying to say like, hey, I am willing to take on some additional complexity, and what I would like in return for that additional complexity is something a little closer to the real world usage of this component.
So what you're gonna test is now is the real. You wanna test is now with this component testing. You are now is testing if this actually works as the way how the users will expect, as the real world suspect.
So yes, you could unit test it, but you're being like, you know what, I would like to very complicated do that like React.create element dance and like all of those things. What we really want to do is we want to see like, hey, is this button disabled? Like, did these DOM changes work the way I wanted them to? If it is like, make sure like the password is a certain length before you enable the submit button, right? Like, generally speaking, you are going to need to hand it to React DOM.render. That's not the name of it anymore. Create root, and like actually be able to use these things. Now, the true other end of the spectrum, as we saw before, was that kind of integration end-to-end testing where build the thing, fire it up in a browser, click the buttons. Like that is the truest version of that. But you do have to download said browsers, start up said browsers, build asset, load into page. Not as fast as like a unit test. Component tests seek to get you somewhere in the middle. I am not, I think like if I was like, for instance, like building a design system, right? I think that I would use a lot of component tests. You know, like even, you know, there are ways to integrate like you're testing with Storybook, stuff along those lines. There's a lot of use cases if you want to like get a lot of the functionality of individual pieces, right? Like,
okay, for UI design
systems. Working on this
systems.
project where we are kind of eventually going to have an extensible UI and the ability to have plugins and stuff like that. Like we will probably take pieces of UI and
Makes
make
a
it
lot
into
of
a
sense.
design system. At which point, like, yeah, that was lightning fast, run through them all, like make total sense. However, like we should go through, we should look at this. You might decide, yes, this like hits the value prop here is amazing for the things that I'm working on. Awesome. I have worked on applications where like our component testing was light because we had like a lot of that, you know, Cypress tests and unit test coverage, and like the value add just wasn't there, right? It is, the goal here is, you know, as we think about these enterprise UI apps or development, is we have an arsenal of tools that is useful for the various ways in which the apps we work on are used, right? We are in this, you know, in this course we have left the this is what you should do all the time area of the world, right? Yeah, you should have tests, like that's, but that's like newsflash for nobody. We are in the here's a set of very specialized tooling that you can use to solve whatever problem that you have, right? Maybe the act of spinning up, like, maybe you're inside of like a much larger application, something micro front ends, and like even like spinning it up in like Cypress or Playwright is like untenable. Maybe you just have a really complicated form, and having to spin up the entire app with all of its dependencies and mock out everything so that you can test all the form validation and whether or not certain things appear in certain states is just not worth it for you, and like too much of a hassle, then like component testing is great, right? And you should totally do it. And if you have a thing where it's like it's very easy to spin up everything and point a browser at it, you might not use it. Those are both really reasonable takes, and like you have both at your disposal. Like even like spinning it up in like Cypress or Playwright is like untenable. Maybe you just have a really right. Maybe the act of spinning up, like maybe you're inside of like a much larger application, something micro front ends, and like even like spinning it up in like Cypress or Playwright is like untenable. Maybe you just have a really complicated form, and having to spin up the entire app with all of its dependencies and mock out everything so that you can test all the form validation and whether or not certain things appear in certain states is just not worth it for you, and like too much of a hassle, then like component testing is great, right? And you should totally do it. And if you have a thing where it's like it's very easy to spin up everything and point.
But the point of this component testing, unlike unit testing, which is per functions, hidden component testing, we want to see is this user interface. Okay. Okay. So unlike unit test, unlike unit testing, where
not some React components are you can't just call as a function, right? Run code, but like for code that you can't just call as a function, right? Code that has one very specific side effect, right? Technically, I guess that works, right? Unit testing super easy. Call function. Did you get what you expected to get?
Exactly. So unlike unit testing, where you test what do you expect to get, okay? So like unit testing, where do you get what do you expect to get? And I think this is important. So do you get what you expect to get? With unlike unit testing, which is this. Exactly. So unlike unit testing, where do you get what you expect to get? Okay. Just like that in a function. In a function. Okay. Unlike unit tests, where you get what you expect to get in a function, okay, which is this, where do you get what you expect do you get what you expect to get into in a function? If it is, all right, if it is, great, cool, awesome. Because component test is usually when you need to test, or when you need to test things with one side effect. Okay, so what does it mean this? So component, a good example of of it is when you need to design a system. When you need, a good example for this is, yeah, a good example for this is, a good example for this is uh, UI system design. All right. When you need to make sure that a particular component, let's say a car with a button, work, for example, it work, for example, in a default state, loading state, invalid state, you know. So that's what you are now is writing your test for that.
That works. And component testing is like the next phase up from there, which is run code. Let's take a
So
look.
if we compare that with what now, they're on fire, bitches. They are on fire. Complete intro to databases. No, what it is the
last section. Buckle up. It's the hardest one yet. TypeScript, definitely the hardest one. Maybe Redux. I don't know. That one's kind of up to you. It's not this one. All right. We're going to talk about testing. If something fails, it damn well better to be telling me something, or it shouldn't have failed. But I hate tests that waste my time. So I'm going to tell you my testing methodology is like, let's write a small core set of very good tests that tell me something. I'm infamous at one of my companies previously for just going in and deleting all the flaky tests. And like, you can't do that. It's like, I'm definitely going to do that. So, here we are. Let's talk about vtest. Every version of this course previously, I think, has used Jest. Vtest is meant to be a drop-in replacement for Jest. So they're meant to be API compatible, which means, so we're going to go into source here, create a directory called __. We'll assume any file back in here. So either one of those is fine.
But this is just a way to actually is.
After yourself as well. So this is not working yet. That's intentional, just so you know.
Exactly, but you are not
This is kind of
explaining is what is this. You're not explaining is now this. You're not explaining this now this stop, spies, and mugs, and into it. Okay.
What this looks like. And so if you look inside source examples counter, I've got this counter test, which is kind of showing you what we can put in there. And I'll flip over to that in a moment, but like look at it here first. It should render the component, right, where we can actually call render, and with some JSX component. I have also, I don't think for this one, I think for the next example, have also done it in Svelte. You will have to squint to see the differences. I don't think for this one, I think for the next example, have also done it in Svelte. You will have to squint to see the differences. The same is true. This is using something called React Testing Library. React Testing Library is a series of tools, like family members include Svelte Testing Library, Angular Testing Library. You've seen a theme here, right? In fact, they're all mostly based on this thing called DOM Testing Library, right? And as you know, at the end of the day, all Svelte and React do is they render nodes to the DOM, right? Yes, something servers are rendered, but generally speaking. And so they're all kind of built in the same framework, and so really it's just a set of, like each one is a set of helper methods. So this will apply whether or not you use React. I just decided that like doing vanilla DOM manipulation is tedious. Most of us probably, even if we work in other technologies, we've probably seen enough React to like at least grok the general concepts. If we use this test, it will fail. It will fail with this reference error document is not defined, which makes sense because we're running a Node, and Node is not a web browser. It's the V8 engine for parsing JavaScript with like, if we're getting pedantic, technically set timeout, set integral are not in JavaScript. They are part of the behavior object model, yada, yada, yada. But like generally speaking, most of the DOM is not present in Node. And so when it looks for document.body or document, like if you look at the code, I think it's like either document.find by ID main or something along those lines. But there's no document. So regardless of whether it's document.body or looking for a main or root node, it doesn't matter because there's no document. Which makes sense because by default, Vitest, and I believe this is true of Jest, runs in Node. Why? Because my golden rule of performance, which is true of the caching, is true here, is that not doing stuff is faster than doing stuff. And so most of the time, not creating a in-memory node-based implementation of the DOM API is faster than doing that. So why would it do that if you don't need it? If you need it, then you can do that. And so the kind of two DOM options that we have.
But again, the entire reason of this, okay, because I want to capture is the essence of this, or try to, right? Or try to, okay, or try to, okay. Recording network requests. Oh shit. Integration testing with Playwright. Getting set up with Playwright. Write some simple write tests. Exercise. Input obstacle. Configuring Playwright. Configuring with Playwright. Exercise. Store an artifact for your Playwright test. Experiment. Get computer style for a DOM node. Mocking routes in Playwright. And recording network requests with Playwright. Oh, I get it. Oh, that's interesting. That's very okay. But right now, let's go with this. Let's go for the testing, component testing. So the idea here is that get some confidence in your UI implement. Okay. So the TLDR, all right. Get confidence about your UI development without needing to spin up without without needing to figuring out how to get a full browser-driven integration. So get confident about your UI development. It's all about confidence. Okay. It's like, hey, unlike unit testing where you're now confident that this function do what it's supposed to do. Okay. Hey, do you get what you expect to get? Do you get what you expect to get it? All right. So do you get what you expect to get it in this function? Yes. And in the context of UI component, it's like, hey, let's now have much more confidence from this UI development for that. Okay, so get confident about your UI development here. Okay, so get confident about your UI development. Interesting. So get confident about your UI development here. Okay, so get confident about your UI development without needing to figuring out how to get a full browser-driven integration, without getting to figuring out how to get a full blown browser driven integration. That sounds a lot of words behind the scenes, right? It's like it's a lot of it might sound like a lot of confusing word, but at the end of the day, it's trying to be precise when it comes to describe what is the thing that it wants to achieve. What is the value proposition of these components? It's that, hey, gain some confidence on your UI developments without getting to figuring out how to get a full browser-driven integration. In other words, so you want to make sure that this UI component works as expected for the real world. So you wanna make sure that your components, your UI component works your component work the way it's supposed to be, just like in the real world, right? When users are hammering that. Okay. At least to give you a sense of what is the thing that I'm doing here. It's like, why am I doing the thing that I do? You know?
Happy DOM, which is kind of new.
Why?
That emulates most of the browser APIs and is allegedly faster.
If this is true, right? Because to spin up a browser from scratch to run your test is something that is resource intense, because you're not only going to now spin up a browser and then run all of these tests, so it uses main memory, CPU, GPU, right? And you want to do that for all of your components. That seems to be not feasible. Or unless you have now a full dedicated hardware to only do that, which is, again, what is the value that we're going to get from this if we have a fully dedicated server out of this? You know, it's just to test all of these UI components. Good. Again, it's too much investment to actually check if that works as expected. You know, So yeah, that's why you have all of these people actually doing this kind of thing until you can automize that, which is
Other than JS DOM,
something that would happen.
I believe that. Instead of legislatively, that's like I feel like undermines it. It's probably faster. And JS DOM, which has been around for at least a decade, possibly more. I forget when Dominic wrote it, but like it's been around
Yes,
forever
sir.
and ever and ever. Which means that one, it is probably incredibly well supported. Two, it probably has a bunch of like old implementations that make it heavier and bigger than it needs to be, and thereby makes it slower. Someone asked at the beginning of this workshop, are we going to use Happy DOM? Generally speaking, I do use Happy DOM. One of the exercises hit one of those, like that word mostly, emulates most of browser APIs. There was one edge case that broke in Happy DOM, and I was like, you know what? If I'm going to be live coding in front of people, I'm going to use the like.
When I
more
live
reliable
coding in
one,
front of
so
people, I don't
flail
want to do that.
wildly about something that's not my fault.
Yeah.
So those are the kind of bugs where there's no reason why it shouldn't work, except for like some implementation, just switching out from Happy DOM to JS
Yeah,
DOM.
definitely don't
no
want.
one wants to watch me do that standing at this podium. So I am using JS DOM. I will say that my default is to start with Happy DOM for that, like it's supposedly faster. Cool, I'm into it. Right, as we talk, this stuff adds up. It's all about the cycles, but also like reliability is also important. That said, I'll show you how you can use like Happy DOM all the time, and then like for one test opt into JS DOM too. But I felt like that was slightly confusing as I was teaching, so I didn't. So that's the kind of origin story there. If you put this in the top of any file, and obviously, like it could be Happy DOM in this case, and the Jest one I think is just Jest environment. You know, most of the same things. Most of it's all the same. You can opt in for one file, right? And I will show you how you can also use pattern matching to be like only for certain kinds of files. So if you go to the top level vitest config.ts, which is like why I have you go into those subdirectories. The top level one is like everything kind of, and it's like mostly done state, and like intermediary ones are down below. You will see, and in fact I'll just show it to you right now and spoil some of the surprise at the end. Which is, you can do these environment match globs, which is I have decided
Interesting.
that, I don't even think I used this one per se, that if it ends in .ts, we'll just use the node. If it ends in tsx, I will opt into JS DOM, right? Or if I have the word component in it or something like that. You know, like you can choose to like do it by file name. You can put it in the ones that you need. You can do whatever you want in this case. Whatever makes you happiest works for me. And then you will have that DOM implementation.
Holy moly, interesting. Okay, you can tell now that at the file level, hey, which interesting. This is also making migrations much more simple. Okay, all right. So that'll be all for the video. Take care. Bye bye.